Welcome. In this video I'm going to show you how you can obtain a common language effect size for a one sample scenario using Microsoft Excel. I have a separate video where I'll be using my own add-in on how to do this, which simply actually has a function to do this, but in this video I won't be using any additional add-ons. I'll focus on how to obtain this effect size measure, not so much if you should or how to interpret it. To show you how this can be done, I have some data over here in column A. This is numeric data, but if you have like ordinal data, you might want to convert it first to a number. And I need to set a hypothesized mean. So in this case, I've gone with the neutral option, which was actually 3. I determine the sample size, which is simply to count the number of scores. And then the first method I've come across for the common language effect size is the formula shown over here, which is actually saying what is the probability of obtaining a score that's higher than that hypothesized mean. So in my case, higher than 3. So what I do is I first determine how many there are. So I use count if. Note I'm using a semicolon. In your version of Excel, you might have to use a comma. Greater than, and then an and sign, and then the mu. So it simply counts how many are above it. So that common language effect size is then simply how many are above divided by the number of scores I have. Now some will argue to actually add half of the number of scores that are equal. So if I count how often actually that hypothesized mean occurs, I can then simply add half to it. So I can actually multiply the previous one, take the previous one and then add half of the number of counts, and then divide by. So I had 13 that were equal plus half of these divided then by the total count. Now an entirely different method is to use the point rank by serial correlation coefficient. I have a whole separate video about that, but that's why these additional columns were here. In short, you need to actually first check, of course, if there's a value there. And we're only interested if it's not equal to the hypothesized mean. And if that's the case, we take the difference between the score and the hypothesized mean. So that's what column B is doing, and column C is actually ranking those, or using mid-ranks to be precise. Once we have those, then I can actually use this function, sum only if it's above that hypothesized value, and subtract if it's less than, so the difference between those two, and divide by the total sum of those ranks. Once I have the point rank by serial, it's easy actually to calculate the common language effect size. I'll simply add 1 and then divide by 2. Another version I've seen is simply using the normal distribution, or the cumulative density function of the standard normal distribution. It takes as input then Cohen's d for one samples. Again, a separate file is available, and video on that. In short, I take the average of all the scores minus the hypothesized mean. So that's the difference between each score and the mean, and then divided by the unbiased standard deviation, sample standard deviation of all the scores. That's Cohen's d, and then I can use Excel's normal standardized distribution function. I'll use this value, that Cohen's d for one sample, over the square root of 2 as my z value, and I want it to be cumulative, and that gives me then the common language effect size. Alright, and that's it. I hope this video was helpful, and thank you for watching.